Hi class, welcome to week number 5, machine learning and linear regression. So let's click on the prep. So as you can see, you're gonna see 4 different files. The first 2 are PowerPoints, one for machine learning to give you an introduction of machine learning, what it is, what it does, difference from AI. And then the second PowerPoint is linear regression. So that's the first model that we're gonna talk about. And then we have a sort of a lecture to show you guys different techniques that we implement. So the linear regression lecture PowerPoint is to give you guys the theoretical part of it, and then the third link, which is linear regression with Python, will be to give you the applicable, to give you guys an example of how to implement the linear regression. We're gonna need this USA housing.csv file to be able to run on your lecture. So we're gonna start first with the machine learning. I'm gonna post that video, create this video first, and then the second for the linear regression, and the third one for the linear regression with Python. For this machine learning PowerPoint, you don't need to take notes. This is just for you guys to have an understanding of machine learning. So we'll click on it, and you can be able to download if you want to, or just see it. So I'm just gonna open that file, and start with the PowerPoint. If it's taking a little longer, you can just download it and open it up. All right, so let's start with this. So machine learning. We're gonna talk about 3 main concepts: the introduction to machine learning, what machine learning process is, and what are the current challenges that we face in machine learning. So some of the things that we have seen machine learning being applied is, something like Netflix, right? It does recommend based on your data of what shows do you like to watch or movies that you like to watch. It gives you a recommendation of what shows or movies you might like. Also, it is very helpful to forecast weather. So that's another very important tool that we have seen it. Other applications that we can see it is an image recognition, speech recognition, fraud detection, self-driving cars, product recommendation, traffic prediction, right? So we can see a lot of now with electric cars and the new technology that being applied, we can see self-driving cars being implemented, right, to be able to make sure that that you can stay away from any crashes. Image recognition from your phones, right, identifies features. Speech recognition for your phone as well, right? A lot of things we have seen in Apple products. Fraud detection to be able to determine if there's something different on your computer that is not normal, so they would determine that as one of the fraud detections. Traffic prediction, as we can see, it gives you a lot of the apps, like Google Apps, gives you the best route possible to be able to get to your destination, predicting some traffic based on the time and accidents in construction. Product recommendation, when we go to Amazon and buy things, right, and we're just looking at things, right, it's gonna give you if you go to a different website, it's gonna recognize that that you're interested in some products, and it's gonna try to persuade you again in the different websites with those same products, right? So that's kind of like to be able to sell more things. So machine learning advancements, absolutely, machine learning has indeed revolutionized numerous fields, reshaping the way industries operate and providing significant advancements in various domains. Healthcare, so hopefully one day, right now it has made a lot of progress, but hopefully one day it's going to be specialized medicine, that where it's going to be specifically to the person's body, that is going to be able to, the medicine is going to be specifically designed for the person's body. Maybe it's going to look at some DNA or allergies that you have or things like that. So finance, forecasting, sales and stuff like that, right? Retail and e-commerce, Amazon products, right? How they tell you which ones you're more likely to buy. Manufacturing, so a lot of robotics has been done, especially like in cars. Transportation, Tesla, natural language processing, education, security and cybersecurity, and many more. So there's some concept that we need to be able to, there's something, 2 terms that we need to understand that are differences, right? What is an artificial intelligence versus what is machine learning? Machine learning is a field within artificial intelligence. So machine learning is inside is part of artificial intelligence. So artificial intelligence is a field of study dedicated to developing intelligent machines capable of emulating human thinking and behavior. So what we're trying to do is we're trying to mimic what a human will do. That's the whole concept of artificial intelligence, just to be able to make a machine that feels human, right? That goes back to the fundamentals of artificial intelligence, which by Alan Turing, a mathematician that became a computer scientist, founder of the first digital computer. And so he set the foundations to artificial intelligence, right? Some of the criteria was, can you, if you have a set of questions for a human in a machine, and you can't tell the difference, right? When you set those questions, right, you can't tell that by the response that they're giving you, that which one's the computer and which one's the machine, right? Then you have an artificial intelligence, right? That's one of the foundations of AI. In essence, AI seeks to answer the fundamental questions: how can we imbue or machines with smart capabilities, right? Machine learning is ML is a specialized branch of AI, so it's within AI that explores the concept of machine learning and evolving without explicit programming. So here, what we're trying to do in machine learning is, can we create a machine that can we create an artificial intelligence that learns by itself, right? That is learning every time, it's learning and learning and learning more and more and more, right? It is improving over as much as more in this case data. As more data we give them, the more it's gonna learn, right? So something like, for example, ChatGPT, it is a machine learning, right? They gave them a lot of information, and then it learned from that data. In simpler terms, ML addresses the question of how can we enable machines to enhance their performance through experience and data-driven learning, right? So the more data we give them, the more it's gonna learn, the better it's gonna perform. So that's the idea of artificial intelligence and machine learning. Machine learning is a field within artificial intelligence, right? Artificial intelligence is we're trying to make a machine feel like a human, right? To act like a human. And then machine learning is part of a field of AI where we're trying to have the machine learn so that it can best perform itself, right, with data. So here's a diagram that kind of gives you an idea of what how machine learning and artificial intelligence behave, right? So we have artificial intelligence, and then inside artificial intelligence we have machine learning and deep learning. There is also the concept of data science, right? Data science overlaps with machine learning and not, right? So there's part of the data science part of it that is within the machine learning. And as we can see, right, when we do machine learning, we actually have to do part of data science. So that's why it's important to do the first part of data science, right, which is extracting the data, cleaning the data, analyzing the data, and then visualizing the data, right? So and so in general, the how you separate machine learning and data science is data science will require a little more programming, a little more statistics, right? And machine learning will require a lot more mathematics, statistics, linear algebra, calculus, right? So machine learning usually involves if we're going to a lot more deep levels like neural network, then that requires graph theory, right? So it's much more heavy math, right? So if you're interested in some of those fields and you don't want to pursue the mathematics part of it, then you recommend data science. But if you're interested in the math part of it, then machine learning will be a very good field to pursue, or deep learning. So what is the difference between traditional programming and versus machine learning? So traditional programming, you teach a baby how to eat a cut up banana. When it is presented with a cut up peach, it does nothing. So now you teach again the baby to eat the cut up peach, right? This continues with every new food you introduce the baby to. So this is kind of like traditional programming, right? We have to tell the computer what to do with a specific task. On the other hand, machine learning is kind of like if you teach a baby how to eat a cut up banana, when it's presented with a cut up peach, it knows to eat it, so you don't have to teach it again. So aka programming, no programming required. So what it's doing here is that based on the information that it was given before, machine learning will be able to know that if he sees another cut up fruit or something, right, it's going to eat it. So that's because it's gonna be able to learn from itself. So that's the difference between traditional programming versus machine learning. right? You don't have to teach it. It will learn. It will eventually learn itself to do what you need to do. So you can teach the you can help the machine learn, and then the machine is going to be able to learn beyond the things that you have given them. Formal definition of machine learning. So machine learning is defined as a computer program. So it's a computer program. A computer program is said to learn from experience with respect to some class of task. So you're giving them data, right, to be able to learn based on it on some task that they some based on the information that you're trying to accomplish, right? So so you give them data, a lot of database, and that data has some output that you want to be able to make sure that it completes, right? And then you can measure that performance. So if it is performance at task in T as measured by P, improve with experience with E. So if it is performance at task in T as measured by P, improved by experience. So as you might see, it might seem a little bit confusing, right? But this is like the definition that Tom Mitchell gave. So let me give you an example. So let's consider an example of machine learning in the context of spam email classification. So here we're using the concept of classification, meaning that it's either a spam email or it's not. Is a good email, right? So in this case, the experience would be the data set of email. So you're gonna give them data, a bunch of data, with the label with either spam or legitimate email. So that's the experience. That's gonna be the experience. So what's the classification? The task will be to classify the incoming emails, either spam or legitimate email. So you can see here that we're given a lot of data, and we want to be able to measure the experience, right? By giving this experience to all this data to the machine, right? We want to be able to make sure that when it completes a task, either classifying an email as spam or legitimate, that it does a pretty good job. So that's when we go to performance measurement. So we want to make sure how accurate is the program, the computer program, which is in this case the machine learning program, accurately determining if it's a spam or a legitimate email. So here is an example of that. So maybe hopefully that example helps you understand a little more about the definition that Tom Mitchell gave. So in machine learning, there's 3 different classifications or types of learning. There is what we call the supervised learning. The computer is given data, and the programmer asks the model to determine the relationship between the input and the output variables. So in this case, you have a bunch of data, and you have what we call your features and your labels. And based on your features, which you're going to give to your computer so you can learn, and you already have your labels, you already know, the computer already knows, dependent on each of your features data, is going to be able to know what the label will be, like the classification. Maybe in this case, let's say it's a spam or a correct email, legitimate email. So you're gonna give them enough data that you're gonna make sure the reason it's called supervised, because you are already telling the computer what is right and what is wrong. So that's the idea of supervised learning, that you're telling the computer, this is given this data, this is what it's supposed to be. Given this other data, this is what it's supposed to be. Given this data, so you're supervising the data, you're supervising the learning of the machine. Unsupervised learning, the computer is given the data with no direction from the programmer, and the computer finds hidden patterns. So what does that mean? In the same example of spam emails, so in this case, we're given a bunch of data, a bunch of emails, and we're not telling the computer which one is a spam and which one is illegitimate. The computer has to determine by itself and classify them as legitimate or spam. So let me go back to the supervised learning, right? Again, with the emails. So in this case, we have a bunch of emails, right? A bunch of data, and so we already know, we're telling the computer, this email is a spam, this email is a legitimate. So that's what it means to supervise, right? So you're telling the computer what is the answer for each of your data. Unsupervised, you're not telling them if your data is good or not. You're letting the computer to understand what it is. It might separate them and classify them differently, but the computer might not know what it means It might find a pattern that groups all the spams together and all the legitimate emails together, but it wouldn't know which one is a spam or which one is legitimate. It wouldn't know what to do with it. But that's what it means to be unsupervised. You're not telling them what is good and what is wrong, right? Um, Reinforcement learning is a model that improves upon itself in new situations using a trial and error method, very similar to how humans learn. So this is a different type of learning. So for example, if you're given the email, so the computer is going to check, okay, is this a good email? And it's going to check with the data that it already contains. If it's good, it's going to be, well, I'm correct, so it's not going to make any changes. But if it's wrong, it's going to make an adjustment to its learning. So that's more like how we usually think. Let's look at the history of machine learning. So, like I mentioned before, Alan Turing proposed the Turing test, which is how we determine the first test that we use to be able to determine if a machine, if we have artificial intelligence, right? So we want to make sure that we want to determine if a machine acts like a human. Like can we tell if a machine is a human or not? So that was 1950. And then in 1952, Arthur Samuel wrote the first computer learning program, the game of checkers. In 1956, the Dartmouth Summer Research Project on AI. 1957, the Frank Roseland designed the first neural network for computers, the perceptron. In 1967, the nearest neighbor algorithm is created, all allowing computers to use basic pattern recognition. So you can see this artificial intelligence has been long before now, right? Stanford University students invented the Stanford card, which can navigate obstacles in a room on its own. In 1996, IBM's Deep Blue, a chess-playing computer program, defeated the reigning chess world champion. In 2011, IBM's Watson computer beat two champions on Jeopardy. And in 2012, Google Brain is developed a neural network able to discover and categorize objects. And then we follow the pattern. 2014, Amazon Alexa is introduced. 2015, Google's Deep Dream is born. It's created a new art from Inceptionists based on the Inception algorithm. In 2016, Google's AlphaGo beat Lee Sedol, a Go champion. In 2017, Google Lens image analysis and comparison tool release. In 2020, the GP3 first is a neural network model that generates any text it generated. In 2020, Microsoft introduced the largest language model ever, Turing natural language generation. And then in 2022, OpenAI ChatGPT, a chatbot built upon GP3 with the human feedback, is released. So that's the one that we've been using or that we've been experiencing, right? A lot of people. What is the process of machine learning? What do we need to do in order to accomplish a machine learning program? All right, so there's 6 different steps that we need to follow to be able to create this machine learning prediction. Okay, so 6 different steps. So the machine learning process is about taking data and producing predictions on other meaningful outcomes for it. Okay, so what the idea, so the first part of it is practically doing a data science concept, right? So it's gonna overlap with data science. So we're gonna collect the raw data. So in that sense, we can collect it from computers. We can collect it from a CSV file, an API, right, or a database. So it doesn't. It really depends on what kind of data you're collecting, right? We're gonna prepare the data. Second step is to make sure that the data is clean, that is not missing anything. That if there is a input value on the data that is not correct, that it might skew our data, we need to remove it. Or if a feature, which is a column, part of the we'll talk about a little more specifically about the features, but it's like, for example, let me give you an example. So let's say that you have a company that wants to predict their they want to forecast their sales in 6 months, and this company is is practically home improvement, right? And within the home improvement, they want to look at different features. Like the features are things that you that would skew the sales for them. So, for example, one of those could be how many people are buying houses, how many people are selling their house, right? How many people are um, have a an extra money in or savings in their account, right? How many people are at home? How much if they're spending more time at home, that might influence their how many people are gonna actually spend money on fixing their house, right? So those are all those things are features that can determine that could help predict if their sales are gonna go up, right? So that's what I mean with determining which columns, which features would influence uh, their prediction, their forecasting. So you have to be able to do that, and the way you do that is by using data science, right? Data visualization, correlations, and things like that, right? So then you have to determine what model selection you're gonna do. There's many different models that we can implement. We'll talk about the different models, right? But we have model like, for example, linear regression, logic regression, uh, k nearest neighbor. We have deep learning. We have neural networks. So many other different models that we can talk about, right? Then we have to be able to validate and improve the model. Sometimes these models might have different parameters that we need to be able to tweak. And so that way we can actually have a better, once we have this model that we have selected, we can adjust the model so it can best fit the data that we have, right? And then we have to make, then we have, after we have validated and improved our model, we can make a prediction of our inference, right? So put simply, data drives, like simply the data drives the machine learning. So it's the machine learning depends on data. Otherwise, if you don't have the data, then you just have an algorithm. So without the data, you don't have the model. And so we'll talk about that. We'll go specifically a little more about that. So in step number one, in most cases, you won't be gathering your own data. Rather, you will utilize data sets that are accessible through corporations or publicly accessible resources. So for example, you can get some data from Google data sets, Kaggle, UCI machine learning repository, government sites. And then for step number two, when you want to, so the first to collect, now we want to prepare the data. You want to prepare the raw data. It's often that disorganized and requires preparation and some analyzed before it can be inputted into the machine learning model. This stage is highly time consuming, consuming approximately 80% of the data scientist time. So this is like the overlap of data science and machine learning. So in that process, right, that's where most people actually spend most of the time, because you have thousands and thousands and thousands of data that you need to fix, right? And you need to be able to determine which feature will be, which column will be the most correlated to your label, to your target. In this stage, you're gonna do data cleaning, data wrangling, data exploration, data visualization, right? So you want to make sure that you have everything clean and in the best fit as possible. So here you can see in this example we have the rows represent data. So examples of data, and here you can see in the columns named there's different. Those are the features of the data. And then you have so most of the time one of those columns will be your target, the one that you're trying to predict. So for example, here we have team Boston Celtics, a number, and here you can see there's some missing data, right? So you want to make sure that when you're cleaning your data that you fill in those information. And if you can't fill it up, then you have to remove it, right? You have to remove that data, so that you remove the whole row. You have the position, the age, the height, the weight, the college, and the salary. And so you can see there's multiple places where it's missing data. So what are you gonna do? Are you gonna do? We talked about how we can clean data, right? We can actually do an average, and if it's like a value, we might do a mean or a value or an average, right? And input the value, or we just extract the data and don't include it, right? So that's the option, right? And so that's part of the preparation of the data. That's usually what requires most of the time. And then we continue with step number 2. Sometimes we have data sets that is biased. So data sets frequently exhibit bias, indicating they are not reflective of the broader population or the individuals the model the aims to assist. So you have to analyze your data and make sure that it's a well-represented data to the population. Because make sure let's say that you're trying to predict the house market in California, and you have data that it includes Arizona, New York, right, or Wisconsin, right? That doesn't It's not gonna be reflected to California, right? Or let's say you're trying to do the prediction of house sales in the United States, but you only have Wisconsin, Wyoming, and Montana, and so that's just gonna be specific to that region. So that's gonna be a bias to that specific region, right? If a model is trained using a biased data, the model will be biased. In the healthcare data, this issue is specifically pronounced as data is often heavily skewed towards white men. So sometimes they just collect data that is specifically to a type of group of people. For instance, the machine model trains on such a biased data set can achieve high accuracy in skin lesions classification for white patients. However, when applied to black patients, the diagnosis accuracy is significantly reduced as models lacks adequate representation of black patients in its training data. So that's being biased. Model selection. Okay, so now we need to determine what kind of model we're going to use, right? There's a diverse array of machine learning models and algorithms available for use. The selection of a specific model, whether it be a regression model, a key nearest neighbor, decision trees, clustering, depends on the various factors. These factors include a preliminary data analysis result. So that's where you actually determine by using the data visualization and data science the type of data being processed, and also your labels, right? You can determine which model you're gonna use, which algorithm you're gonna use for your data, and the specific task or objective you are aiming to achieve. The appropriate model will be chosen based on these considerations. These are some of the models we're covering, right? Linear regression, the k-nearest neighbor, the logistic regression, decision trees, and random forest, natural language process, so and many more. But this is some of the models that we're going to talk about. All right, so step number 4, we need to be able to train the model. So notice that we're going through every single step, right? First, collect the data. Second, prepare the data. Third, choose the model. And now 4, we need to train the model. So this is a very important part of the machine learning. So once you choose your algorithm, you need to train your model. It is common to split your data into data sets. So this is a very common procedure, right? So most people use an 80-20 separate division. So what you do is you divide your data between training and testing. The reason that you want to do that is because you don't want to you don't want to have data that was being trained to be able to test your data, because otherwise it's kind of like already it's gonna be overfitting your data. So it's gonna be already it's gonna be already it already had learned from that. So your prediction will not be relevant, because it's gonna be dependent on the data that you actually have used. So you want to be able to separate your training data and your test data. So you don't want to have any of your test data in your training data. So that your machine can learn, right? So you want to separate that. Sometimes, if we can, while we usually don't have enough data for this, we will ideally split the data in 3 distinct data sets. So sometimes we want to split it into 3: training, validation, and testing data. So the reason that we want to do this is because when we actually separate this into training and validation and test, so it allows us to be able to make, by having this valid data, it allows us to be able to have to be able to change our parameters so that it can so that we can best fit our model. So that validation data is going to be used before we test it, to change the parameters of your data, of your model. So the next, and continue with training model. The training data must meet two requirements: the large enough to yield statistically meaningful results, representative of the data sets as a whole. During training, the model learns important characteristics of the training data. Step number 5, once we have trained the model, once you train the model, you work on improving the accuracy of the model. One way to do this is through the hyperparameter tuning. So this is, some of the models we have some parameters that we can tune, so that we usually call them hyperparameter tuning. So we're just changing the numbers there to be able to get the best possible model fit. During this stage, we usually use the validations data set to test the performance of the model as we make changes. So that's why we want to have that value. Not all of them have require or have a hyperparameter, but some of them do. So when you do have a hyperparameter, you want to be able to separate your data into 3 steps, so that in 3 groups, so that you can actually use it to tune your hyperparameters. Step number 6, after refining the model to the best possible extent, the next step involves making the inference and predictions depending on the type of the model used. These final predictions are generally used on unbiased test data sets, ensuring the model performance is evaluated on previous unseen data. So this is where we have already using our test to make sure that your data is correct, right? And then we can make our predictions. We can use our data to make predictions. So remember, your test data you have the information about your test data. If you're using a supervised model or supervised learning, you already know what the outcome should be, right? So you already have the data it's supposed to be. So you're testing it, and you know how accurate this is going to be. And here's where you're gonna be able to measure as well how accurate your model has been. Okay, so you're actually using your test data to be able to see what the prediction of your model would be, and determine by measuring the performance how well your model was fit. Some of the current challenges that we face is data quality and availability, the need for large amounts of data while ensuring individual rights to their privacy, as well as getting comprehensive data sets and representation samples. So that's always going to be a big struggle, right? Some people want to keep the information private, and so we have to respect that part, right? But in the same sense, where do we draw the line? Where can we actually use the data for the comment of the people, right? So there's a lot of laws that need to be respected to be able to do that. Or sometimes, some people might, like, if you're a politician or something like that, then you have to make a big decision and for the well of the country. Then you have to make decisions that is going to impact the privacy of some people, right? Or maybe is in a hospital, right? And you want to be able to have help patients to predict heart attacks, and some people might not want to share their information, right? So that's something that we need to be able to figure out. Interpretability and explainability, the ability to understand and explain how the machine learning model arrives at its predictions or decisions. So sometimes, especially in neural networks, it's very hard to be able to see how the computer actually came out to decide the prediction. So it's very hard to be able to argue that, how did the computer find this pattern, and be able to say, well, based on this, because thinking that you can see it, right? You're gonna be able to argue that this is how the machine was able to predict this person. And so that comes to a very important topic, right? So let's say they use machine learning to determine if somebody was a murderer, right? And so how can you explain that in court if you cannot understand how the machine came to the conclusion, right? Especially with neural networks, it's very hard. So that's an example. That's something that we're still currently as a challenge. Privacy and security, the protection of sensitive data against privacy concerns, security risk, and adversarial attacks. Yeah, of course, every single time, right? Generalization, the ability of machine learning models to perform accurately in unseen data. So how can we determine if the machine is correct, right? Ethics and bias, right? Even at ChatGPT, we can't be 100% sure that the information is correct. ethics and bias need to be for comprehensive ethical frameworks that are adhered to across industries and countries, right? Can we draw a line? How can we use this AI, right? In the ethical and without, um, bias to anybody. For example, let's say that they use machine learning to predict if somebody should get insurance, right? And maybe this machine learning is taking information the wrong way, or the people in the company is taking it the wrong way, right? Not wanting to